Welcome to UGC lecture series in computer science on software engineering. We are seeing a series of lectures, and in this session we will be discussing about the debugging strategies and about the test case strategies. Now let us see what a defect is. A software bug arises when the expected result do not match with the actual results. It can also be an error or a flaw or a failure or a fault in a computer program. Most bugs arise from mistakes and errors made by developers and architects. Following are the methods for preventing programmers from introducing bugs during development. They are the programming techniques adopted, software development methodologies, peer review, code analysis. What is a software bug? In software testing, when the expected and actual behavior is not matching, an incident needs to be raised. An incident may be a bug. A bug, it can be a defect. It is a programmer's fault where a programmer intended to implement a certain behavior, but the code fails to correctly conform to this behavior because of incorrect implementation in coding. A bug is also called as a defect. Now let us see about the defect logging and defect tracking. A defect logging is a process of finding defects in the application under test or product by testing or recording feedback from customers and making new versions of the product that fix the defects or the client feedback. The defect tracking is an important process in software engineering as complex and business critical systems have hundreds of defects. The number of defects gets multiplied over a period of time, and to effectively manage them, defect tracking system is used to make the job easier. Now let us see the life cycle of a bug. I said the bug is also called as a defect. So let us see the life cycle of a bug or a defect. When a new bug is come in, so this bug, this defect, it will be assigned to the development team, and this bug now it is active. So this active bug will be tested by the testing team. After testing, if the bug has been cleared, it will be verified, and if it is verified and if the bug has been eradicated, then it will be closed. If the bug has not been closed, then it will be either that particular bug will be rejected or it will be deferred. Now after testing, if there is an issue even in coding, if it has not been closed properly, if the issue has not been able to be resolved, then the bug will be reopened and again it goes to an active status. So the procedure follows. So the loop follows again and again. So this is the life cycle of a bug. So let us give in detail about each and every phase in the life cycle of a bug. Now we have the new phase determines it is a potential defect that is raised and yet to be validated. Assigned phase determines assigned against a development team to address it but not yet resolved. Active states the defect is being addressed by the developer and investigation is under progress. At this stage, there are two possible outcomes: either the bug will be deferred or it will be rejected. The testing denotes the bug is fixed and ready for testing. Verified speaks about the defect that is retested and the test has been verified by QA. Who is a QA? Quality analyst. By the quality assurance team, it has been verified. Then closed determines the final state of the defect that can be closed after the QA retesting, or can be closed if the defect is a duplicate defect, or can be considered as not at all a defect at all, can be considered as not a defect at all. It will be reopened when the defect is not fixed, or when the QA thinks it should be reopened or it should be reactivated. Deferred, when a defect cannot be addressed in that particular cycle, it is to be deferred for future releases. A rejected case is one wherein a defect can be rejected for any of the three reasons. That is, if the defect is said to be a duplicate defect, or if it is not a defect at all, or if it is not reproducible. Let us see the common types of defects. We have the arithmetic common, which is said to be the most common type of defect, wherein people make the arithmetic errors. The coders, when they code, they miss out certain arithmetic factors. So this defect is said to be highly common. So we have an arithmetic defect, we have logical defect, we have syntax defect, we have multi-threading defect, we have interface defects, we have performance defects. Let us take the parameters that are required for defect tracking. When a defect has occurred, any defect should possess a defect ID, or it should be assigned a defect ID, and priority for clearing the defect has to be set, and the severity of the defect has to be measured. And when that particular defect has occurred, the creation date of the defect has to be noted down, and to whom or to which development team this particular defect has been assigned, and that has to be noted down. And when is that defect been resolved, the resolved date has to be noted down as well. Who resolved it? The resolved person, the person or the development team, whoever has resolved it, has to be noted down. And then the current status of the defect has to be jolted, and that denotes whether a defect is cleared or whether it is not a defect, or whether the defect is deferred or whether a defect is rejected. So this speaks about the defect tracking parameters. Next is, let us see what is a failure. Under certain circumstances, the product may produce wrong results. Failure is defined as the deviation of the delivered service from compliance with the specification. Not all the defects result in failure, as defects in dead code, that is unused code which is not at all being used, do not cause a failure. Let us now find out the reasons for failure. Environmental conditions which might cause hardware failures or changes in any of the environmental variables. Human error while interacting with the software by keying in wrong inputs, because people may not be highly committed, people may not be keying in always. So to errors human, so that denotes over here as human error while interacting with the software by keying in wrong inputs. Failures may occur if the user tries to perform some operation with intention of breaking the system. Now let us see the results of failure. When a failure has occurred, it denotes loss of time, loss of money, loss of reputation, injury, and it may also result in death. So these are some of the results of failure. Let us see what a fault is. We have seen about failure. Now let us see what a fault is about. Software fault is also known as the defect. The defect arises when the expected result do not match with the actual results. It can also be an error, flaw, failure, or fault in a computer program. Most bugs arise from mistakes and errors made by developers or architects. Let us see the different fault types. There are business logic faults, functional and logical faults, faulty graphical user interface which is being given as GUI, performance faults, and security faults. Now let us see how to prevent those faults. Programming techniques, adopting the correct programming techniques and adopting the exact software development methodologies and peer reviews and code analysis. Now, if a fault has occurred, let us now see how to inject the fault injection testing and the methods that are available or used in the fault injection testing. Now, first of all, what is a fault injection testing is all about? A fault injection is a software testing technique by introducing faults into the code for improving the coverage, and usually used with stress testing for robustness of the developed software. Now, let us see some of the fault injection methods. One is the compile time injection. It is a fault injection technique where source code is modified to inject simulated faults into a system. Other one is the runtime injections. It makes use of software trigger to inject a fault into a software system during runtime. So, these are the two fault injection methods. One is compile time injection, other one is a runtime injection. Let us see what is a debugging all about. A debugging is a systematic process of spotting and fixing a number of bugs or defects in a piece of software so that the software is behaving as expected. Debugging is harder for complex systems, in particular when various subsystems are tightly coupled, as changes in one system or interface may cause bugs to emerge in another. Debugging is a developer activity, and effective debugging is very important before testing begins to increase the quality of the system. Now, let us see the debugging processes. The problem has to be identified and the report has to be prepared. So, the debugging process lies in problem identification and report preparation, assigning the report to software engineer to the defect to verify that it is genuine. The defect analysis uses modeling, documentations, finding and testing candidate flaws. The defect resolution by making required changes to the system, validation of correctness. So, these factors speak about the debugging process. Then, now let us learn about the several debugging strategies. The study of system for the larger duration in order to understand the system. Backward analysis of the problem, which involves tracing the program backward from the location of failure message in order to identify the region of faulty code. Forward analysis of the program involves tracing the program forwards using breakpoints or print statements at different points in the program and studying the results. Using the past experience of the software, debugging the software with similar problems in nature. The success of this approach depends on the expertise of the debugger or the person who debugs it. So, everything lies based on the experience of the debugger. Now, let us see some of the debugging tools. Debugging tool is a computer program that is used to test and debug other programs. The examples of automated debugging tools include the code-based tracers, profilers and interpreters. My dear students, we have seen about debugging in this session. You would have learnt about testing in the earlier sessions too. So, now we will clarify the major difference between testing and debugging. So, the testing focuses on finding bugs, errors, whereas debugging starts after the bug has been identified in the software. So, this is the basic difference between testing and debugging. The other differences are: testing is used to ensure that the program is correct and it was supposed to do with a certain minimum success rate. Testing can be manual or it can be an automated testing. There are several different types of testing like unit testing, integration testing, regression testing, system testing, smoke testing, alpha testing and beta testing. My dear students, I suppose you would have studied all these type of testings in the previous sessions. The other major differences between testing and debugging are: debugging requires a lot of knowledge, skills and expertise. It can be supported by some automated tools available, but is more of a manual process as every bug is different from one another, and it requires, and each and every bug requires a different technique unlike a predefined testing mechanism. Now, let us see about a test case. A test case is a set of conditions or variables under which a tester will determine whether a system under test satisfies requirements or works correctly. The process of developing test cases can also help find problems in the requirements or in designing of an application. Now, let us see the testing strategies. So, usually the testing strategy differs from model to model. When we use a traditional life cycle model, again my dear students, you would have studied about various traditional life cycle model like the usage of the waterfall life cycle model, which is as well called as the linear sequential model, or it is also called as the classical life cycle model. And apart from this, you would have studied details about the prototyping model, the spiral model, the rapid application development model, which is shortly called as the RAD model, joint application development model, which is also called as the JAD model, and so on. So, the testing strategies involved in those traditional models, or again they are all traditional. Now, let us see the testing strategies that are being used in the agile models. Again my dear students, in the earlier sessions you would have studied about the various agile methodologies like extreme programming, which is commonly called as XP, the framework Scrum, Crystal methodology, DSDM, dynamic software development model, Crystal model, lean development, agile software development ASD model, and so on. So, let us see about the test strategies that are performed in the agile software development lifecycle models. So, this agile software development lifecycle model, the strategy is being supported by DevOps and it requires continuous testing. What do you mean by DevOps? DevOps denotes development and operations. So, in the case of agile lifecycle model, wherein in the case of Scrum framework, wherein you use sprints, the duration of sprint is only 15 days, that is a fortnight, and it has a maximum duration of sprint can be of 1 month. At the end of each sprint, you might be aware that you are supposed to deliver a small feature, which you term it as a minimum marketable feature. So, when you are going to deliver a small minimum marketable feature to your customer at the end of each and every sprint, definitely you are supposed to make a continuous testing. Then only the customer will be satisfied, then only your minimum marketable feature will be working. So, this continuous testing is followed in this agile testing strategies. So, this continuous testing is important to improve the product quality. In agile development, testing needs to happen early and often. Tests are prioritized just like user stories. My dear students, again you might be knowing what a user story is. Testers aim to get through as many tests as they can in an iteration. I repeat, testers aim to get through as many tests as they can in an iteration. Now, let us see what are the do's and don'ts of an agile testing and what sort of typical activities that an agile tester has to do while he is doing the agile testing. Now, first let us see about the do's in agile testing. You need to encourage test automation selectively, periodically. Domain knowledge is a vital factor for the QA members. Certain degree of technical competency is essential for the QA members. When they are going to test it, they are supposed to have the technical complexity expertise. Then only they will be in a position to understand how the bug has come in, how it has been rectified, how it is working in. Then testing as early as practical, and the testing should be made continuously. That is, when you are going to do a coding wherein the testing, you are supposed to do testing several times in a day. It is not that during the end of the day testing, it is not the end of the day testing. When you are going to do a coding, you are supposed to test your product, test your feature several times in a day. That is called as a continuous testing. Developing acceptance test cases before the software is designed. The other do's in the agile testing are: the developers have the responsibility to create automated unit tests. They have to make testing and feedback a continuous activity in a sprint rather than a phase towards the end of the life cycle. Testers must be in continuous conversation with the coders, and my dear students, the coders and testers, they have to join hands when they are testing it. So that is the reason we have quoted it as testers must be in continuous conversation with the coders. Continuous build and integration practices will aid in testing. Now, let us see the don'ts of agile testing. We have seen the do's in agile testing. Now, let us see the don'ts in agile testing. Expect a sign off or baseline the requirements. Who will do the sign off? So, get the sign off from the customer end. So, expect a sign off or the baseline the requirements. Create an elaborate test plan. Expect separate daily stand-ups and separate planning and estimation processes among development and QA teams. The other don'ts in agile testing are: follow manual testing entirely, disconnect from the customers and the development team, participate only towards the end of the sprint, ignore system testing since unit tests exist. My dear students, all these points will lead to negativity. That is the reason I have given in the title as don'ts in agile testing. These are the things you are not supposed to follow. So that is the reason it has been given as don'ts in agile testing. Now let us see the typical activities of an agile tester. The tester should raise queries on the testing needs for the requirements and should adapt and should aptly identify the missing bug. He should understand the acceptance criteria of a story and perform testing based on the acceptance criteria. He should try some negative testing story within the limit of the user story. In case of failing scenarios, the tester should raise a defect on the cards. The tester should notify the status and defects that have been identified so far. Tester should automate the story covering all the acceptance criteria. The tester should automate whatever defect is fixed if it is not covered in any story. The testers after interacting with the business analyst, should perform exploratory testing to look into some missing functionalities that has not been covered in the stories. So, these are some of the typical activities of an agile tester. Now, let us summarize of whatever we have seen in this session. We have seen about what a defect is, what a bug is. Both defect and bug are one and the same. What a failure is, what a fault is. So, defect, and we have as well seen the strategies for debugging. We have as well seen what debugging is, and we have seen the strategies of debugging, and we have seen the basic differences between testing and debugging. The debugging strategies were discussed in detail elaborately. The test case and agile test strategies were discussed. The do's and don'ts of an agile testing and the agile testers were made known. The typical activities of the agile testers were explained in detail. These are some of the references that are quoted for your future study. Thank you.